So today we're going to be talking about functions. So we're going to identify the domain and range, determine if relations are functions, use function notation, and then finally evaluate functions. Okay, so our first term today is a relation. And a relation is just any set of ordered pairs. It's how X relates to Y. Okay. The domain is the set of first components in an ordered pair. All right. Or in other words, the X values. So if we just jump down here to example 1, if we are asked for the domain, we are looking at the X values of the ordered pairs. So my domain in this case, and you kind of just put it in brackets like this, is going to be -2, 4, 8. Okay, now we do have another 4 listed in there, but if a number is repeated, you only list it once, and you do want to make sure you put it in order from least to greatest. All right, and then the range is the set of the second components of the ordered pair, or in other words, it is the Y values. So these Y values would be considered the range of the function. And again, we just put it in brackets. Our smallest number in our range is 0, then 1, then 6, then 7. Okay, and then a function is a relation in which no two ordered pairs have the same first component and different second component. So in other words, each X value, I'm going to highlight this in red here, each X value, there is only one Y value. Okay, so if we look at our example down here again, you'll see that we would say that this is not a function. No, this one is not a function. Why? Because if you look at the number 4, it has the same X component that goes to a different Y component. So this one is not a function because 4 goes to both 6 and 7. Okay, so those are a couple of our definitions along with that first example. Just 2 more really quick definitions. An independent variable is the X variable because any value can be assigned to it. So independent, okay? You can pick any X value. But then whatever you pick for X creates a dependent variable, which is Y, because when you plug in X, you get a Y. So therefore, Y depends on what X is. Okay, so independent is an X variable, dependent is a Y variable. Okay, so I would like you to go ahead and tell me what is the domain for letter B. All right, there you should have just listed all of the X values from lowest to highest. Now go ahead and list the range. All right, for this one, you should have just listed all of the Y values in order from lowest to highest. Okay, we did have 3 repeating, and remember we only put that in there once. Now tell me whether or not this is a function. You should have had that yes, this is a function because every X value goes to a different Y value. Okay, now that can be a little bit confusing because we do have a repeated Y value, but remember our definition up here. Each X value, there is only one Y value, not each Y value, there's only one X value. Okay, so that only goes one way. You just have to have unique X values. Okay, so this one pretty straightforward. Our domain is going to be, well, they list what our domain is there. So we're going to have -3. And then our range is going to be on the right side. Now, notice I did not list 8 in my range, okay? Nothing goes to 8. There's no x value here that is pointing to 8, all right? So is this a function? Well, each one of these arrows goes to a different, or each one of these x's goes to a unique y. So therefore, we would say, yes, this is a function. In circumstances like these, when they set the problems up like this, the way that you can tell it's not a function is, let's say this number 1 also pointed to 8. You see how 1 is going to 2 different numbers? In that case, this would not be a function. Okay, now you can also determine if something is a function or not by doing what's called the vertical line test. So if you're given a graph, if you draw a vertical line, you would be able to tell whether or not this is a function. All right, so I'm actually going to do example 2 first because I think that makes it easier to see. If I draw a vertical line anywhere on this graph, anywhere, notice that it's only going to hit my function 1 time. So this would be an example of, yes, this is a function. Now, if I draw a vertical line on a graph and it hits my function in 2 different places, is this a function? No, it is not. Okay. So if I just come back up here, if I draw a vertical line at any of these points, it only hits 1 point. So this one would be, yes, it is a function. But if I come over here for letter B, if I draw a vertical line, it hits that point 1 time. If I draw a vertical line here, you can see it hits 2 different points. So no, this one is not a function. Okay, so that's how you can use the vertical line test to determine whether or not something is a function. Okay, now function notation is just like writing something in the form y equals mx plus b. But instead of the y that it doesn't want me to highlight, nope. Instead of the y, they substitute that with an f of x. And that's called the function notation. F is the name, x is the domain, and f of x, or y, is the range. Okay, so what these types of problems are going to look like is they're going to tell you what number to plug into the function, and you're going to find what the range is according to what they tell you to plug in. So what do I mean by that? For letter A, it says f of -2. Okay, so I am going to take my f of x function, and I am going to plug in -2. I always say, like, there's an x here, so there's an x here. So if there's a -2 here, then just plug in -2 into the function. 1/2 -2 squared plus 1. All right, we're just plugging that in. So that's going to be 1/2 of 4 plus 1, which is 2 plus 1. So f of -2, that's how you would say it, f of -2 is equal to 3. Okay, we just plug it in. Now letter B says take the g of 3. So now we're looking at this function g, and there's an x here, an x here, and an x here. Well, if I'm taking the g of 3, I am plugging 3 into all of those places. So this is going to be 3 squared plus 5 times 3 minus 1. And you can type this all in your calculator in one step. I'm just kind of doing it the long way. So 9 plus 15 minus 1, g of 3 is equal to 23. 3. All right, next we have h of -7. So now I'm traveling over here to my h function. I have an x here and an x here, and they are telling me to plug in a -7. Oops, +2. Now, if you forgot what those vertical bars mean absolute value. Okay, and absolute value is the distance something is from 0. All right, so if you get absolute value, your answer is always positive. So this one's a perfect example because when I go through and do this, I get the absolute value of -5. All absolute value means is that it is always positive. So this is just going to turn to a +5. Okay, so there's 3 examples for you. I would like you to go ahead and solve for the g of -1. And when you plug -1 into the g function, then you should get -5. All right, now we're looking at the domain and range of a graph. And I remember this being super confusing for me when I was in high school, so I'm going to do my best to explain it. So remember we said the domain is all of the x values on the graph. Now, keep in mind, like this is an x value, this, like every single thing on here is an x value. And we're not going to go through and list every single decimal that is in the domain. So what we do is we just list what the domain is between. So remember, domain is the x values. The lowest x value on my graph here is -3. And the highest x value on my graph here is +4. Okay, and then we are just going to put that in brackets. And then I'm going to do the same thing for my range. The lowest number in my range is -1, or my lowest y value, and the highest is 5. Okay, so that's what it kind of looks like if you have a graph that has a beginning and an end. But if you look at letter B, you'll notice we have arrows at the top. Okay, so that means that graph goes on and on and on and on forever into infinity. Okay, so if I'm looking at my domain, okay, my x values are going to go on forever and ever and ever because that arrow tells me that this graph is going to go on forever and ever and ever. So therefore, my lowest x value is -infinity. And then same thing the other way, this graph is going to go on forever and ever and ever and ever this way. So my highest number in my domain is +infinity. Now my range is my y values. So if I look at my y values, my lowest y value on this graph is -2. But if I try to go and look at my highest y value on the graph, this graph goes on forever and ever and ever up. So the top of my range is +infinity. Okay, so when you see arrows on the graph that go on forever, that's how you know that there's going to be some infinities in your domain and range. Okay, so using the first letter A as an example, go ahead and find the domain of this function. Your domain should have been -4 to -6, the lowest x value to the highest x value. All right, now do the same thing for the range. All right, your range should be -2 to 3. Again, lowest y value to the highest y value. Okay, now use the first letter B as an example in order to find the domain of this second letter B. All right, your domain should be exactly the same as the first letter B. It goes on forever and ever this way for x values and forever and ever this way. So your domain is -infinity to +infinity. Okay, now do the same thing for the range. Remember, it has to be the lowest value to the highest. All right, so the lowest value on that graph is negative infinity, right? If I start at the bottom, these arrows tell me I'm going forever and ever in the negative direction. Okay, and then my highest y value is up here at this point at 3.